Hello class. Now what we have to do next is we have to solve for the other two surfaces between 5 and 3. Let's say we want to calculate what will be the relative motion threshold for the surfaces 5 and 3. In that case, what we need to do, we take 3 and 5 as one block and 5 as the other block. So when you take 3 and 5 as one block, you get the equation F minus now 0.2 into mass, which is 5 into 10 is equal to what to us? 5 into acceleration. What acceleration? F minus 10 by 10. Which is to get us F minus, this becomes for us 1 by 2, right? 2 by 10. So this becomes to us 5 is equal to F by 2 minus 5. From here, F by 2 is equal to how much to us? Is equal to 10 minus 5. So F is equal to how much? F is equal to 10. We get to see from here different values. What about this one? F minus 0, this becomes 10. 0.3 was given to us, 0.123, that becomes 6 is equal to F by 5 minus 2. F minus F by 5 is equal to 6 minus 2, 4. 4F by 5 is equal to 4, so F is equal to 5. These are the values post which relative motion will get set. This is one question, important one. The other question, interesting. A phenomena given to you where this is a pulley with certain mass, so go over this. This then goes over this one. What is interesting about this question is, they have asked you about what will be acceleration of M1, what will be acceleration of M2. What is interesting about this question is, this question cannot be realized because you cannot see the system stable from ground. If you are on ground and try to establish this system wherein string is massless, pulley massless, there are two masses given to you. You want to realize there will be only one solution to it, which is t equal to 0. You can see from here, this is t, and right, this will be how much to us, this will be t, right? 2t from here, dt, and this is t, and this is t, this is t. So we get t is equal to 2t, solution possible only for t equal to 0. Now this bewilders us. Why? We are perplexed. How is this possible? Does it mean? Now decoding is important over here, deciphering is important over here. When you decipher it, you need to understand it doesn't mean that string will break. What means that the system cannot be realized. But the answer to this question will be G. Now tension 0, G, or is more than what meets the eye. We cannot realize the system as seen from ground, but we can realize the system from an elevator which is falling freely under gravity. There you can. If you are placing ourselves in the elevator, right, then we'll be able to meet this situation. We'll be able to see this. In that case, what we can say about acceleration of M1? Acceleration of M1 will be G, and so will be acceleration of M2. This elevator should be falling freely under gravity. In that case, it can be realized. Then comes another question, as it is not lagging, I am proceeding with the question. It lags, then I stop. So, there is a bucket of mass m0 and particles are dropping in the bucket, vertically dropping in the bucket at the rate of n particles per second. Each particle is of mass m0. There is a force F applied to it. Skip on a smooth surface. What is being asked is, find the time when velocity, when speed of this body will reach half of the maximum. What will be the time and the speed of this body will reach half of the maximum. So why will there be a limit, a cap to speed? That is to be realized, that is to be thought over, brood on it, go on and check. Why is that there will be a limitation, there will be a threshold, or you may say the benchmark beyond which it cannot rise. It can go up to that, post that it is to Plato, post that it is to Planck. So why that cap? Why is there a rider? What we can do best is mathematically we can check for a situation when a mass collected is m naught I have taken for this. So mass collected is, this is m naught, this is mass collected is mn and mass of the block is m naught. So this is the mass. It is moving with v and then we can write force into dt. This is what we can write. Force into dt, change momentum for that time. This can be marked as f into t, and the momentum change from 0 to b. So v is equal to how much to us? ft divided by m theta plus m. Okay. See, this is change in momentum. Change in momentum is equal to what to us? Is equal to force multiplied by time. Now change in momentum, initial being 0, what is the momentum now? This mass has been collected, so eta m, and mass of the body m into v is equal to this much we are getting. From here, maximum is what to be gotten is f divided by eta m. I am just dividing by t, this is by t, and t tends to infinity. So this is the maximum speed it can go up to. Time in which half of it being achieved, m theta plus m naught into t we can mark, into v we can mark, and is equal to f into t. Now t replacement, this v will be replaced by what we want, half of this. So m eta plus m naught and half of that value, f by twice and m is equal to what to us? F into t. F and f gone, t is equal to what to us? Twice and m, right, just check. You want half of it, half of the maximum. So we'll have to take half of the maximum. And then from there, 2nm divided by mn plus m. Maximum speed is this. You want time in which half of that is being achieved. So maximum being this is the equation. We are working again on this equation and we want v to be replaced by half of that. That is what we are doing, half of it. And from here we get to see what is the time required to achieve half of the maximum speed. These were the questions. There are many questions coming. We will check those questions. Few of the interesting questions which I would wish to take. This is a square, this is a tube, there are two particles over here, they start sliding. Can the system leave the surface? Okay, I have finger off, or to just pique your interest, what all we'll be taking in the session this year. Thank you.